Hi, I'm Mike McLean. Welcome to the Short Circuit podcast brought to you by Swift Aircraft. In this series, we'll be chatting with a variety of people from all walks of life, but who all have one thing in common: aviation. We'll discuss how and why they got into aviation, what or who inspired them, and what they would say to encourage young people to get involved. Flight fascinates many of us, and our guests will explain why they are compelled to look to the sky. Today's guest on the Short Circuit is Tim Bridge. Tim is a force of nature when it comes to getting things done. I've been aware of him for the past few years, and I'm impressed by the progress he's managed to make on the project he's running. By sheer weight of personality, focus, and demonstrable capability, things tend to happen when he gets involved. When you learn about his background, then it all starts to become more apparent why this is so. His passion for and knowledge about aviation are obvious, and while his love of the technical detail quickly comes to the surface, his explanations of the big picture and the broad brush thinking behind the detail make his objectives very clear. I suspect that his approach will be quickly adopted and deployed around the world where a need for his solution is required, and that is probably much larger than you might think. To understand what I mean, let's listen into the chat. Okay, so good morning, Tim Bridge. Welcome to the Short Circuit. And we start off with our question number one, which everybody gets, and that is, who are you and what's your role in aviation? So a quick intro, if you would be pleased, sir.
Certainly, I'll try. No guarantees how quick it will be. My name's Tim Bridge. I'm one of the founders and the technical director pro tem at Nuncats, which is a social enterprise doing electrification of bush planes. And our role in aviation is that we're doing the electrification of bush planes for the most part, essentially doing what we can to demonstrate what's possible with the extant technology.
Excellent. That's a very succinct and precise explanation. Thank you very much. So to get to know you a little bit, question number two is, can you give me a summary, or what was the incident that first got you interested in aircraft and aviation?
That probably predates my effective memory, to be honest. I grew up as a sort of airline brat to some extent because my father worked for Rolls-Royce. So we were always posted basically off the end of some runway somewhere because he was a service rep and we hung out at and around airports. So it wasn't so much that there was any single instance that introduced me to aviation. Mm-hmm. It was just always there, and I was never told that it wasn't normal to basically be at or around an airport on a regular basis.
Right.
So okay. it was sort of a default in my early years, to be honest.
And did this take you around the world much? Did you get to see many places?
Not all aviation related, but I think if you only count countries I've lived and worked in, I think the count is 39 or 40 at this point. There or thereabouts. So yeah, been around a bit.
Yeah, that's gonna broaden your horizons, especially as a young person. That's gonna expose you to an awful lot of stuff.
Yeah, certainly that's when I was traveling around as an airline brat as a child. It was South America, Middle East, and Asia, and then when my own career got going, it was another 30 countries after that. So yeah, it does give you a slightly different view of what the world is and where the challenges are and what is and isn't worth doing.
Mm-hmm. Okay. Well, that brings us on. So when you said your current role, so how did you get started? What is your current role, not just with Nuncats, but I'm assuming that you've been involved in other aspects of aviation before you started Nuncats. And so what's the background? What's the backstory?
Well, there was a gap, to be honest. My first role in aviation was working on gas turbines for Crossair out in Basel, A2100s, if anyone actually cares. I was supposed to be going into the Air Force, but for reasons I won't bore you with, I managed to dodge that bullet. So then I went off in a slightly different direction for a good number of years, went via offshore geophysics, various oil and gas and energy related type of engineering and project engineering roles, and then sort of came back into aviation, not by accident, but sort of tangentially, because I remember that I did used to quite enjoy that kind of thing. Got back into getting my flight training started again. And off the back of that, I started looking into non-certified or amateur-built aircraft and how that industry works, both in the US and in Europe. And that was ultimately what led us to the conclusion that by putting the right skills in the right rooms, we could actually come up with useful, cheap electric bush planes that could fill a niche that aviation hasn't really even looked at in about 50 or 60 years.
Right. Okay. Which leads us very neatly onto question number 4, which is what developments and innovations do you anticipate in the near future of aviation? It sounds like you're at the cutting edge of that. So here's your chance to give us the pitch on Nuncats.
Well, ironically, we're not at the cutting edge. We're 1.5 steps away from that, because what we're after is simple and reliable. So yes, it's an electric aircraft, but the cell chemistry we're using is 2016 vintage. So it's not bleeding edge at all. It's what you can do reliably now. But moving forward, I think certainly in small aircraft, primary trainers, that kind of thing, 2, maybe 4, 6-seaters, electric drive with probably not batteries as we know them, but supercapacitors, aluminium air technologies like that will definitely have a role to play in the near future. Obviously, a lot of work going into hydrogen, but I think from my understanding of it, the sort of break-even point where the juice is worth the squeeze on that is in a slightly larger aircraft. And then, of course, all the big boys are looking 30, 40 years ahead with blended bodies and whatever propulsion system comes along in the intervening 20 years. But that's beyond my ken to even comment on, to be fair.
But so leaving aside the sort of the big stuff for the future, you're focusing on, you've described as electric bush planes. So what's the role for that, and what's the advantage of electricity?
Well, I mean, the ones we're looking at are specifically targeting sort of last mile, mostly clinical issues, so midwives, paramedics, to an extent general practitioners, people like that, who at the moment have no transport option for 15, 20, 30 kilometer journeys across very difficult terrain. And because they're fairly remote areas, you're not going to get a reliable supply of fuel in most of these places. If they had a reliable supply of fuel, they'd already be flying Kit Foxes or Zeniths or Overlanders or whatever. But the advantage of electric, as we see it, it's not even about decarbonisation or anything like that. It's about the fact that it's got 3 moving parts, and you can charge it off solar panels that every hospital already has.
Right.
So it's predominantly about separating the owner-operator from a long supply chain involving not just the fuel, but also the regular oil changes and all the other maintenance that goes with a traditional single-engine piston, which you just don't have in an electric drivetrain. We're talking 400 hours between services, and the 400-hour service is an inspection, 2 Jubilee clips, and a pint of coolant. It's a much lower service overhead. And say most of the places where these could be genuinely useful, they get their electricity to run their fridges and their lighting from solar anyway. So actually optimizing to sort of piggyback off that existing infrastructure is a way to have real impact more or less immediately.
Right. Okay. So you've identified a niche requirement and have found a solution that's using existing technology in an existing airframe, which you're modifying to go from piston engine to electric. Is that fair enough?
Yeah, more or less.
Okay.
We're doing as little engineering as possible, because that's how you keep them simple and cost effective.
Right. Okay. So, and for those who aren't familiar with your type of aircraft, I mean, what does it look like? How's it? I mean, is it a thing or?
It's a two-seat, high wing, tricycle gear, 650 kilo max gross, entirely conventional in every way. So 3-axis control. It's got elevator, rudder. It has flaperons instead of ailerons and flaps separately, but with the difference between the clean stall and the flaps down stall speeds is 2 knots or something. So
Right.
I think most people who fly these sort of admit that flaps really don't get an awful lot of use. So it's a fairly conventional 2-seat high wing. It from a distance, if you squint, it's not that different from any of the high wing Cessnas that flight schools use. It's
Right.
just a little bit more rugged, fewer curves, a few more sort of slabby flat bits,
Hmm.
but it's essentially a fairly conventional high wing tricycle gear
Right.
2-seat
Okay.
aircraft.
Okay. So your construction of this aircraft, I believe, is aluminium. Is that? Oh,
Yes.
predominantly aluminium. Right.
Yeah, it's vast majority of it is aluminium. It's 6061 T6 for the most part. There's a few curved bits which are plastic, wing tips and horizontal stabilizer end caps, things like that. The load-bearing subframes that carry the motor and such like are steel, the same as they would be in most motor mounts in any light aircraft. Tend to be sort of chrome moly steel of some sort. And then there's a few composite bits, cowls and such like, but predominantly, yeah, it's folded sheet metal.
Right. Okay. That sounds so very simple to make, simple to assemble.
Yeah, one of the joys of the Zenith airframe, one of the reasons we chose it was its simplicity of assembly. The genius of that design isn't, and I say this with the greatest respect for the designer, it's not necessary. It's not aerodynamic efficiency or elegance beyond the fact that form follows function, and therein lies a type of elegance. But they're incredibly easy to build. And of all the kit planes in the US market, it's quite a big market. It's about $1 billion per year. They're at Zenith are the best selling, and one of the reasons they're the best selling is that most of the ones that get sold actually get finished, which
Right.
is rare in most manufacturers. It's a bit like Coleman's mustard. They made their money from the mustard people left on their plate. I get the impression that the kit plane market is somewhat similar. An
Yeah.
awful lot of manufacturers do very well out of people who buy a crate of parts but never actually do much with it. But the Zeniths, that they tend to get built because they are very straightforward to assemble. It's all self-jigging. There's very few parts of the process which are difficult, to be fair.
Right. Yeah. So the midlife crisis market can be quite lucrative, I think.
Well, Zenith are in the middle of basically doubling the size of their factory. During COVID, their waiting list for a new kit went from sort of 5 months to over a year at one point,
Wow.
just because there was an awful lot of people who decided that they wanted to be in the garage, not the living room during lockdown. Maybe, I don't know, but they're currently up at well over 100 kits a year leaving the factory.
Right. Okay. So, so we've instantly made the assumption that we're looking at middle-aged men building kits, but I believe you have quite a high involvement in STEM activities.
Oh, absolutely. I mean, one of where what we do is very firmly based on 3 distinct but cooperative pillars, shall we say, and one of them is very much the STEM involvement, because these aircraft are very simple to build. They're ideal to get young people into building, and not necessarily even in an aviation context. Even just teaching the basic hand skills of whether it's just sheet metal work or whether it's the more generic how to work as a team to put an assembly of parts together. The fact that you're working on an aircraft is a good motivator for most young people because planes are cool. But actually, what we're teaching in the sort of the pop-up STEM events we do and the more formal sort of summer schools and academy programs, the team building and the how to follow instructions and how to delegate and how to, well, honestly, how to fill out the forms. That's all good stuff, which is very transferable, whether it's people coming into aviation who know nothing about it, who are actually practically very skilled, but don't know anything about how planes go together, or conversely, young people who are more interested in the electronics or the software side of it, still get to be involved in a real aircraft in a way which most sort of projects available to 16 to 20-year-olds don't really allow them to do. And that's ultimately where we're having done programs like that for a couple of years now. What we're looking to do in 2024 is have student cohorts start to finish, build an aircraft, test it, and then prep it for shipment so it can go to someone in the developing world who actually needs to use it. So we've got UK skills providers who have, for example, undergraduate B1 or B2 trainees who get really valuable experience in mentoring other young people. We can have young people from schools who have nothing really to do with aviation come in and do a day's work and learn what's available in aviation from a skills point of view and career pathways point of view. And at the end of all of that, we get an aircraft that we can send to a charity that flies paramedics around Uganda at the bare minimum of cost.
Right. Okay. I mean, that's fantastic because some of our other guests have been involved in build a plane projects for fun, but this is taking it one step further, taking it into the real world and actually deploying these aircraft and these skills into the places that require them.
Well, that's the idea. I mean, at the moment, more or less, just you have to cast a fairly broad net because this is a slightly odd pitch, to be fair. But Uganda is a use case where we're furthest along, just because we happen to have met people who operate in that part of the world already. So we're talking to the CAA in Uganda about the basis for approval out there. We've already got a flight school that does a lot of outreach work with women and girls, specifically towards flight training and aviation skills. They've got a hangar just down the road from where we want to operate. And the airport where we want to fly the kit into has a college just down the road who can be upskilled to do all the basic maintenance requirements on an aircraft of this type. And none of that would be possible if you assume your aircraft has to be certified. Mm-hmm. Because as soon as you require licensed engineers and yellow labeled parts, it suddenly can't do the job we need it to do. So you alluded earlier to the fact we've identified a niche use where this can be useful. It is a niche, but remember, there's 1 billion people on Earth with no functional access to healthcare. Mm-hmm. I mean, it's a niche, but it's a non-trivial niche.
Yeah. Oh no.
You've got to start somewhere, haven't you? Yeah. So almost by accident as much as design. While we have got case studies in about 8 or 9 countries now, it looks like subject to finding a suitable sponsor for that particular build. It looks like it'll be built in Cambridge over the Easter holidays. It'll be finished and tested at Old Buckenham over the summer holidays, and hopefully we'll be in Sarotti late next year.
That sounds fantastic. I really, really look forward to seeing the results of this. And yeah, I mean, I'm glad you pointed out that there is a global need, and I think it's very easy, especially with aviation, to get caught up in first world problems without acknowledging that there are these bigger problems where aviation can assist around the planet. Because a lot of people, their only experience of flying is to get to Benidorm and back, and that's the thinking. And we need to open up minds to the broader aspects of aviation. It's not just EasyJet and Ryanair.
No, I mean, I would obviously tend to agree with you that while commercial air transport is obviously a very, very large industry, it is also very risk averse because of the capital that's tied up in the hardware.
Yeah.
You can't develop a machine to transport hundreds of people at those speeds and have a less than about 20 or 30-year service life, because you'll never get your investment back. And that puts a lower limit on what the industry as it stands can develop.
Right.
You cannot, I mean, this is why obviously Swift will be well aware of this, but primary training aircraft in the UK, average age of 60 years?
It's not
Because
far.
no one's building affordable small aircraft anymore because the market isn't big enough, so they're just not building them. The cheapest Cessna you can go and buy now is $250,000
Mm-hmm.
at least. I mean, by the time you've actually put any instruments on it, you're spending $500,000 on a 172. And actually, that we have to find ways of creating lower cost solutions.
Yeah. Yeah.
Which is what we're doing. May be one way of doing that.
Yeah, excellent. Well, that's fantastic, Tim. Time is marching on, and it's flown by, no pun intended. So we're going to end up with the hardest question for all our guests on the short circuit, and that is, what is your favorite plane and why? And it can be anything, and I'm sure you've got more than one.
That's not a difficult question.
Go ahead.
The de Havilland Mosquito.
Okay. Would you like to tell us a bit more about it?
Partly because my father nearly bought one off the Venezuelan Air Force for $10,000 in 1980, and my mum wouldn't let him. Because he was national service when the RAF still had a few. So he was Rolls-Royce engineer, so obviously Merlins.
Yeah.
But the Venezuelan Air Force had a few that they'd acquired from the Canadians, I believe. But anyway, they were mothballing them finally in 1980 and were selling them off, and he got offered one cheap. Anyway, so I've known about them forever. It was like the second Airfix kit I ever built in 1982 was a de Havilland Mosquito. And then years later, I actually looked into the thinking behind them and how off the beaten path de Havilland was when he was convinced that bombers should be light and fast, and you didn't need all the guns and all the armor because you just outrun everything, when the rest of the world was just throwing more 50 cals at it and putting more armor on it. And he was building a sophisticated composite aircraft that was just outrunning everything. So I've got a lot of time for not only the aircraft in terms of the power to weight ratio and the speed and the elegance of the thing, also the fact that it was a bit dicey to fly, so that they only gave it to good pilots. But I'm fine with not dealing with mediocrity. I'm okay with that approach. But also the approach that led to its creation. The fact that he was quite happy to put a line in the sand and go, no, I'm doing it this way, and I'm going to keep doing it this way until someone realizes I've got a point. I'm not comparing what we're doing to de Havilland, just so you know. I'm not a complete egomaniac, but there are parts of that story that resonate, and it's a very pretty, very fast aircraft. And don't tell the guys at Swift, but I'm scheming up a plan to do an electric 75% scale one, because it would be a fantastic toy. And it would help pay for the good stuff that we're trying to do.
That sounds like something we should be having a further conversation about. That sounds fantastic.
All right. I think it would be a fun little single-seater, wouldn't it?
It's wow. Yes. Don't even start that conversation just now. We'll come back to that at a later date.
I'll just send you the CAD files and let you stew on
them. Pass them on to Julian. He'll be all over it.
Excellent. I'll bear that in mind.
So Tim, right? So I'm going to wrap this up now because you're a busy man. You've got things to do. So just in summary, so you're building this. I think the phrase Sky Jeep's been kicked around as well. So.
Technically, the Sky Jeep as a term was first coined for the Zenith 701, so the smaller version of what we've got now. Although a lot of Zenith customers sort of universally just refer to any of the high-wing Zeniths as Sky Jeeps. So we just borrowed that term and stuck electric on the front of it.
Right.
Because
So Nuncats.
hence electric sky jeeps.
So you're making the electric sky jeep, and you found where the need for such a vehicle is, and you're going for it. You're involved with STEM, and I think the words entrepreneur and pioneer could be used quite happily in the. Don't look so modest. These are.
I'm not happy with that, but
But no, Tim, it's been great talking to you. And thank you very much for joining me here on the short circuit. And I shall speak to you some point in the near future.
no problem. Yes, we'll catch up soon. And you're right, it was a hard question. I'm already second guessing myself as to whether that there are definitely close on the heels of the mosquito. But anyway,
The
I have now
mosquito is
committed
now
to
going
it.
on our virtual control tower wall alongside a bunch of other aircraft. And what I can tell you is it hasn't been put there before. So
Excellent. Good,
so,
good. Well, that's no excuse to not do it in my experience. So happy days.
So that was Tim Bridge. I think that you'll agree that for most of us, his upbringing would be considered somewhere between unusual and exotic, and being immersed in the world of aviation from the start has certainly influenced his thinking as an adult. Being able to identify the needs of the communities around him and generating activity that serves that need is a skill that many of us would struggle to bring to reality. Being able to do it across the developing world where the need for the electric sky jeep exists, and to do the same thing in his local community by providing skills and education engagement and the #inspiring aviation ethos is, I think, quite remarkable. So when you see a future news report about the emergency medical aid being delivered to some far-flung location by a solar-powered electric sky jeep, remember that these ideas have to come from somewhere. It's not often you get to talk to someone with that sort of vision, but that's all part of getting involved. Here on the short circuit. Fly safe. You have been listening to The Short Circuit, presented by Mike McLean and sponsored by Swift Aircraft with the #InspiringAviation. This has been a Zoom Spike production.